Okay, so there's one more type of asymptote that can occur in a rational function, and these are called slant asymptotes. Now, slant asymptotes only show up under a very specific set of conditions that occur. So first off, slant asymptotes are going to, first off, be a contender if there's no horizontal asymptote. So we're already talking about that we have a bigger power on the top than we do on the bottom. So it's got to be that bot-nose situation. Now, the other thing that has to happen is the degree of the numerator has to be exactly one power higher than the degree of the denominator. So the powers can only be off by one. So we're talking, I have an x squared over a plane x, or an x cubed over an x squared type thing. Now, if it is an x squared over an x plus or minus a number thing, then we can use synthetic division to figure out where that slant asymptote is going to sit. If it's anything else, so if it's an x squared over a 3x plus 2 or an x cubed over an x squared, you're going to have to use long division in order to figure that out. Okay, so let's take a look at an example here. So we've got find the slant asymptote of this one. So they're kind of already indicating that there's going to be a slant. So we've got 2x squared minus 5x plus 7 over x minus 2. Okay, and I'm actually going to do a little bit more with this just so we've got a couple of little things. Okay, so first off, if we were going to talk about domain, which is where we would probably start, we've got x minus 2 can't be 0. So we'll add 2. So x can't be 2. Now that means we're vertical asymptote, okay, is going to be an x equals 2. So we just get rid of the slant, okay? So now, if we were going to talk about horizontals, okay, our biggest power on the top is a 2. Our biggest power on the bottom is, they didn't put one here, so it's a 1. So we are in bigger on top, no, so it's a bot no, but we do have that 2 is exactly 1 bigger than 1. So we do have that it will have a slant. They kind of already told us that, but we're still kind of going through our process. Now, because this is x plus or minus a number, we can do synthetic division to sort this out. So I'm going to put my 2, -5, and 7 right there. Again, opposite end of the box. So we're going to put a positive 2. And then we're going to run our synthetic division. So I'm going to drop a 2. 2 times 2 is 4. -5 plus 4 is -1. 2 times -1 is -2. 7 plus -2 is 5. Now, keeping in mind that this was x squared, this is x number remainder. The only part of this is the part that's an actual line. So our equation is going to be 2x minus 1. Okay, so that's going to be the equation for our line. Now, graph picture. What are we looking at? Okay. I've got a vertical one at 2. So I'm going to go draw that in. And then I've got to do my line at 2x minus 1. So we're going to start at -1. And then we're going to go up 2 over 1. So we're just graphing a line. Okay, so we've got this. Now, where does this graph live? I don't know. Maybe it sits over here and does kind of a big arch curve over here and another big arch curve over here. Or maybe it arch curves here and then it's tucked up real tight in this smaller area. Maybe it's up here in this little area and down over here or here and here. I do know that it won't be up here in this little one and in this big zone right here because it still has to be a function, okay? And it also won't be in these two zones over here. But this is now how we get our slant asymptote into the picture.